Hi, this is doing balancing equations with Legos, doing just simple equations. So the next one that we're going to do is decomposition. I don't know if you have to know that term, but for decomposition, you take something that's simple, two elements put together. It can be more than two, it can be 4, 6, 8, it doesn't matter how many, but you have a couple of things that are put together, and then in decomposition, they break apart, they break down. So in this simple example, it'd be AB breaking apart to be A plus B, okay? So from your problem set, we're gonna pick number 13, and we're gonna do AG2O breaking down to be AG plus O2. Now AG, if you remember, is silver, and O2 or O is oxygen. So in my method, I like to draw a line so I know that everything on this side of the arrow, like an equal sign, is equal to everything on this side of the arrow. I'm going to write down so that I can count all of my atoms, and I have to have the same amount of silver as I have on both sides, and I have the same amount of oxygen on both sides. I'm gonna put blanks beside them so I can write everything down. Now for step one, I always start with 1. You never know, it might work out okay. AG, we have 2 of them here, times the 1, so that's 2 times 1 is 2. Here we just have 1 times the 1 for the oxygen. Over here, the AG, we have only 1 of them times the 1. With the oxygen, we have 2 times that 1, so we end up with 2 of those. Now, as you can tell, those don't match. 2 and 1 for oxygen does not match. 2 silvers to 2 silvers does not match. Here's where we bring in the Legos. And so I'm going to use red and blue to symbolize our different atoms, okay? So here I've got our silver and oxygen put together, 2 reds and 1 blue, and I go ahead and I link them up because that's symbolic of the bonding. And then over here, I've got 1 silver and the O2 already bonded together. Now, it's really easy to see with the Legos, this does not match up. We don't have the same amount of reds, we don't have the same amount of blues. So what can we do to fix this? So this is where we have to start working towards a solution. So rewrite it, leaving yourself enough room to put blanks. And this step is the part that people usually hate because I hate having to write it again. You can try erasing it or doing markouts on your paper, but that might end up also getting confusing and it makes it hard to show your work. I like just working it and going down every time I make changes. Occasionally, if it's something very small, I'll go ahead and do a cross out. Now, when we go back and we look at our Legos, we can see we're gonna have to have more reds. We have to be able to have more reds. We know we could put just 2 reds here, but there's a problem. We need to have more blues also. So what if we go ahead and have another one of these and then see what'll happen? Now that gives us 4 reds, and over here we're gonna need 4 reds as well, right? So let's try putting in those numbers and see how things work out. So over here we have 2. Here we have 4. And here we have, remember, they're linked up, so 1. This is just 1. Now let's count. How many of our red silvers do we have? 1, 2, 3, 4. How many blues do we have, our oxygen? We have 1, 2. Pardon the coughing there. Over here, we've got 1, 2, 3, 4 reds for our silvers. And linked up in our oxygen, we have 1, 2. Now, let's go ahead and start looking over our numbers. Do our silvers match? They do, and they do with our Legos. Do our oxygens match? They do, and they do with our Legos. That's a solution. That problem is done. Now, on your problem set, they get more complicated than this, but it will still work. Everything I've shown you will still work. And anytime you have something where it's got its 2's, and if it's written together, make sure they're stuck together. And you don't have to do this with just Legos. You could do it with crayons. You could do it with anything. I recommend colors because it's easy to see, but anything, if you have enough of them to count out for the different atoms that you're using. Thank you for watching this. Again, this was decomposition reactions. You don't have to know the name of it, but there's a bunch of them on your problem set. Thanks.